In this class, we're going to take a look at Pythagoras' theorem. So Pythagoras' theorem is for right angle triangles only. So if you're going to use Pythagoras, you've got to know that it's a right angle triangle. So either by the symbol on the triangle, or it could say in words in the question, for example, triangle ABC is right angled, but you've got to have that confirmation that it's a right angle triangle first before you can confidently use Pythagoras. There are other techniques for non-right angle triangles. So sometimes a question will look like a right angle triangle to try and lure you into thinking it's Pythagoras when actually it's another technique. So be careful with that. So what does Pythagoras actually say? Well, it says that if you've got a right angle triangle, so if you definitely know it's right angled, and let's call the sides A, B and C. Well, it says if you take the two short sides, so these are the two short sides, this is the long side, the hypotenuse, then if you add together the squared versions of A and B, so A squared plus B squared, that equals C squared. So that's true for any right angled triangle. The important thing is not the letters. Don't get hung up on the letters because every question is going to use different letters. I see a lot of students getting very hung up on A, B and C, but for example, a question might have, you know, this is A and this is C over here, or some manipulation. So just think instead about short sides and long side. So maybe a better way to write the equation, or at least a better way to think about it, is that it's the two short sides squared. So let's just call these the short sides squared equals the long side. If a question uses A, B and C, that's great. If not, then don't get too hung up on the letters. So there's basically two types of question here. There's questions where you're going to be asked to find the long side. So that's going to be a missing side in the triangle, and it happens to be the long side, or a missing side, which is one of the short sides. That's all we can really do with Pythagoras. There's nothing in Pythagoras about these angles here. That's SOHCAHTOA. That's using sine and cosine in the trig ratios. So you may have seen those questions before. Pythagoras doesn't say anything about those. It just says we need a right angle, and then we're going to use this equation over here. So Pythagoras is actually a little easier, I think, than working with like sine and cosine and tangent. So what do we do? Well, this question here is asking us to find the long side. Let's just nominate a letter for that because we're going to need to do some algebra in a moment. So we can just set these numbers up into our equation. So the two short sides are 7 and 24. So let's go 7 squared plus 24 squared equals the long side squared, which is C squared. These are generally going to be calculator questions unless the numbers are quite small. You would never be asked to do 24 squared manually unless you've got a very mean math teacher. So we just need to process the numbers basically. This is the difficult thing, getting it set up in the first place. After that, it's just being careful with the numbers. So 7 squared is 49. 24 squared is 576, I think. I don't know that off the top of my head. I checked that earlier on the calculator. That equals C squared. If you add those guys together, it comes out to be 625. Now, 625 is not our final answer. Obviously, that would be way too big for side C, because that's equal to C squared. So we need to square root both sides of the equation to get the C value. Or you could just think of that as going straight to C equals the square root of 625, and the square root of 625 is 25. So that's come out to be a whole number. They don't always come out to be whole numbers. This one over here is working with decimals. It will come out to be some decimal number. So that's our final answer for that one. So that tells us that this side length is 25. These questions will sometimes have units. Usually they will have units. So I don't know, it could be centimeters or something like that. Just make sure that you get the units onto the final question. Onto the final answer, sorry. So let's assume that these guys are in, I don't know, let's say that these ones are in kilometers. So that's basically how we use Pythagoras. That would be for finding the long side of the triangle. That's probably a slightly easier case, I think, than this one. This one we've got to manipulate the equation a little. So let's just nominate a letter. This time the side we're trying to find is a short side, Let's just call it A. It doesn't matter if you call it C, it really makes no difference. Don't get hung up on the letters at all. Think more in terms of the equation. We're just going to plug the numbers into the equation in the same way. So these are the two short sides. So A squared plus the other short side, which is 1.5 squared, equals the long side squared. So that never changes. You're always setting up like that. The two short sides added together, squared added together, equals the long side squared. So again, it's now just a case of processing the numbers through. This time though, we've got to also move that number to the other side. So it's kind of solving an equation at this point with squares in it. So what we're going to do is just start by processing the square. So 1.5 squared is 2.25. Again, this would be a calculator question. So I checked these numbers earlier. 2.5 squared is 6.25. And then we're just going to go ahead and add, take this one away by moving it over to the other side. So we're going to end up with a squared on the left-hand side. I'll just write in the line of work in here. So it would be 6.25 minus 2.25. So it's really that line of working that makes this one more difficult than this one. We didn't have to manipulate the equation really here. We just added our numbers and square rooted at the end. Here we had this line where we had to move that term over to the other side so that we end up with the thing we're trying to find on one side and the numbers on the other side. That was already the case here. The C was on one side and the numbers were on the other side. So 6.25 minus 2.25 just comes to be 4. So that's a little nicer looking. So a squared equals 4. A is going to equal the square root of 4, which is 2. So the final answer for this one would be 2 kilometers. It's always worth with these questions checking on the diagram, because normally you do get a diagram for these. In fact, it'd be very strange to not get a diagram. So it's always worth checking on the diagram, does that make sense? So going back to this one, this was the long side of the triangle we were finding. So it has to be a number bigger than 24 and 7. So if this had come out to be like 17, then something's obviously gone wrong. The long side can't be a smaller number than the short sides. So that does actually fit in quite well with the geometry. Looking at this one, the 2.5 is the long side, so the A value has to be smaller than 2.5, but not massively smaller, because you can see by the geometry here that it should be, I mean, my diagram is not perfect, but it should be somewhere around 1.5 to 2.5. So the fact that it's come out to be 2 looks fine. If it come out to be 0.5, that doesn't seem quite right. If it came out to be obviously anything bigger than 2.5, then it's definitely not right. So use the geometry to almost help validate that your solution makes sense. So quick recap, Pythagoras' theorem only for right angle triangles. You need to know it's a right angle triangle, and it just says that the sum of the squares of the two short sides equals the square of the long side. Sometimes you'll use that directly to find maybe the long side. Sometimes you'll use it, well, not directly, but indirectly, in the sense that you've got to manipulate the algebra to find a short side. The main thing with this is really just to gain a bit of experience. Try questions that fall into both categories. A lot of students get these work quite well done, but then they get muddled on these ones and maybe move the numbers in the wrong way or something. That's why it's a great idea to check with the geometry that the answer makes sense. If you make a mistake in your working, the final answer will almost certainly not fit in with the diagram in any way. It'll be some crazy answer. So just checking as you go along that it does give you an answer that kind of makes sense and fits in with the geometry. So not too difficult, Pythagoras. It's more difficult to use in context. So in another class, we're going to look at how you might use Pythagoras, not just in a straight up way like this, but you have to work a little harder to even recognize that it's a Pythagoras question in the first place. In terms of the mechanics, just actually using the technique, it's normally fairly straightforward, but does take a bit of experience. So it's worth spending a bit of time trying out quite a few practice questions on this topic, because Pythagoras is a popular question type. It never really goes away. You'll use it in a bunch of math courses in the future, so it's a good one to get really good at now.